all the elements in the circuit, they consume some energy. There is some dissipation of energy, and there is continuous dissipation of energy, but that is compensated by the source that is generating this field. So hence the total energy of the field is kept constant by the source. So it is the source endeavor to maintain the constant energy in this field. Okay, so that's the reason we refer to this field as a conservative field. Okay, so that is a constant field, constant energy field. So the energy in this field is neither increased nor decreased due to the movement of the charges, and that is taken care by the source, and in this case it is electric charge Q. Clear to all of you? Okay, now when RA is equal to RB, mathematically, yes, we know that it is a closed loop, so line integral E dot dl is equal to 0. Okay, line integral E dot dl is equal to 0. And if you apply Stokes theorem to this equation, Stokes theorem converts line integral to surface integral. So this is surface integral of del cross E dot ds is equal to 0 without loss of generality. Okay, and ds is not equal to 0, or del cross is not perpendicular to ds, so we could consider del cross E to be equal to 0. So this is in integral, this is in point form, and this is in integral form. This is the first property of conservative field. So when I say conservative field, immediately you should think about this property. And what is that property? Line integral E dot dl is equal to 0, or del cross E is equal to 0. So del cross E is equal to 0 will result in the second property of conservative field. So see, these properties are actually they refer to the mathematical model associated with the conservative field. Okay, so as I told you earlier, and we will be using these mathematical models every time in field theory, because we can't do experiments here. So we are trying to understand these concepts, and concepts can be understood only by considering these mathematical models. So del cross E is equal to 0. What does this mean? The curl of electric field is equal to 0. And if you remember the basic identities, one of the identities that we discussed at the end of vector analysis, curl grad f is equal to 0. Right? So curl of the gradient of scalar function is equal to 0. So del cross E is equal to 0, which means that E bar can have a form like E bar is equal to K into del F. This, for example, where K can be some scalar quantity and F is some scalar function. So E bar will have this form, right? This is K into del F, some scalar multiplied by the gradient of a scalar function. Then only the curl can become equal to 0. That we already know, right? Now we have to understand what is this K and what is this F. Okay. For that, let's take the help of V potential, that is V is equal to minus integral infinity to capital R E dot dl. What will be the case? Differentiate on both sides. What do you get? You get dV as minus E dot dl. We are convinced of the fact that V is a scalar quantity. It's a scalar function. From vector calculus, dV can be found out as dou V by dou x dx plus dou V by dou y dy plus dou V by dou z dz. Correct? Can I also write this as dou V by dou x x cap plus dou V by dou y y cap plus dou V by dou z z cap dot dx x cap plus dy y cap plus dz z cap. Is this correct? Then what is this dou V by dou x cap plus dou V by dou y cap plus dou V by dou z cap? Del V dot, what is this dx x cap plus dy y cap plus dz cap? dl bar. And we already know dV as minus E bar dot dl bar. So what is the relation between E and del V now? E bar is equal to minus del V. So this could be taken as a second property of a conservative field. Okay. So when you say conservative field or electrostatic field, then immediately you should think about these two properties. One is line integral E dot dl is equal to 0 or del cross equal to 0. The second one is E is equal to minus del V. So electric field is equal to the negative gradient of the scalar potential or negative gradient of a scalar function. So if the scalar potential V of xyz is, say for example, given as 50x square plus 50y square plus 50z square volts in the examination, they ask you to find out electric field, then use the relation E is equal to minus del V. Depending on the coordinate system, whether it is Cartesian or cylindrical or spherical, you have to find out the gradient and put a minus. That will give you the electric field E bar. Okay. Now take a note. If del cross F is equal to 0, where F is in general some vector field, what is this type of field known as? If del cross F is equal to 0, then F bar is known as irrotational field. Irrotational field. Why is it called irrotational field? Because the curl of the vector field is equal to 0. Del cross F equal to 0 means what? It is a curl that is equal to 0. And curl is related to the rotational nature or the circulatory nature of the field. So it is called irrotational field. If del cross F is not equal to 0, then what is this type of field known as? It is called rotational field. These are all important 1 mark questions. Non-zero curl is referred to as a rotational field. Then if del dot F is equal to 0, what is this field known as? In general it is known as divergence free field. Divergence free field or solenoidal field. Okay. So divergence free, which means there is no divergence associated with this field, right? That's correct, because the del dot F is nothing but the divergence of the vector field. And why is it called solenoidal field? So you need to wait till we start a magnetostatics chapter, where we will see that magnetic field forms circular loops in the transverse plane, which appears like windings on a solenoid, and so this is referred to as a solenoidal field. Okay. So del cross F equal to 0 can be related to the electrostatic field. You see, you have del cross E equal to 0 for electrostatic field, right? So electrostatic field is a irrotational field. So there is no rotational property associated with the electrostatic field. So, or sometimes it is referred to as non-conservative field, right? Sorry, conservative field. It's not non-conservative. Del cross equal to 0 means it is a conservative field. So irrotational field or conservative field. If del cross F is not equal to 0, then it is called rotational field or non-conservative field. So in the examination you may refer this to as irrotational field or conservative field. So he may give you the equation for E bar or equation for F bar, something like kx cap plus y cap plus z cap, where k is a constant, and then he may ask you to find out the value of k if it is a conservative field or if it is a irrotational field. Then take curl to be equal to 0 and solve for k. Important 2 marks question, frequently asked question in several PSU exams.